So Tyler, you can put your video back on so everyone can see you. Tyler Takashita is a quantum solutions architect with AWS focused on Amazon Braket. Prior to joining AWS, he was a lead of quantum technology at Mercedes-Benz Research and Development North America, a Daimler company. Tyler received his PhD in chemistry in 2015 from the University of Illinois at Urbana-Champaign, specializing in theoretical quantum chemistry. He then went on to be a postdoctoral fellow in the College of Chemistry at the University of California at Berkeley. So, Tyler, you can start anytime. And for some reason, there we go. Great.
Oh, thank you very much, Susan, for that kind introduction. Like Susan said, my name is Ty Takeshita. I'm a specialist solutions architect here at AWS, supporting the Amazon Braket service. And today, I wanted to talk to you about Amazon Braket and how you can access D-Wave devices through our service. As many of you are probably aware, you can already access D-Wave devices through D-Wave's Leap Quantum Cloud service. But I wanted to talk about an alternative path there through AWS. So just a quick outline of what we'll cover today. I realize that many of you may have little to no experience with AWS. So I thought it'd be good that we started with a brief introduction into what AWS is and some of our services, our general services, and what we provide to our customers. Then go ahead and focus on what we're doing at AWS in the area of quantum computing, not only with the Braket service itself, but kind of a little broader than that. And then go ahead and focus in on the Amazon Braket service itself. I'll cover some of the architecture, how it works, our pricing model, and point out a few key features that I'll revisit when we hit the demonstration portion of the seminar here. Okay, so what is AWS? Well, AWS is the world's most comprehensive cloud platform, and we provide our customers with on-demand delivery of IT resources. And we do this through a pay-as-you-go pricing model. And so what that means is that there's no upfront commitment, and you really only pay for what it is that you use. And so for our customers, this means that there's no more buying, owning, maintaining of data centers and servers. You simply acquire the resources like compute, storage, or database, and now quantum computing resources on an as-needed basis. And we have the broadest range of services available. Now you'll see here that we have more than 175 fully featured services. And in 2019, we launched over 2,000 new features and services. I think Amazon's a really good example of how it is that we continue to expand our offerings to our customers. It was released in August of 2020. And since then, we've added support for Penny Lane, as well as continue to build out the number of simulators we have. We've introduced the Tensor Network Simulator, or TN1, and I'll cover that in a little bit. Well, who is it that builds on AWS? Well, we have businesses of all sizes from various industries. These businesses range from startups with just a few employees all the way to large businesses with thousands of employees around the world. And over the past 12 years, we've had tech companies like Airbnb, Pinterest, and Slack build natively on the AWS cloud. And this really allows our customers to be very agile and flexible, to try fast and fail fast and learn fast. Makes them very innovative. But what are we doing in the area of quantum computing? In addition to the service that I mentioned, right? So Amazon Braket is a fully managed service aimed at democratizing access to quantum computers. But we also have two other things that I'd like to highlight here. On the right-hand side of the slide, you see we have the AWS Center for Quantum Computing. And so this is a research center close to Caltech, the campus of Caltech, and it really brings together the world's leading quantum computing researchers and engineers. And they have a mission. And this mission is to push the boundaries of quantum technologies through fundamental research. And so, as time goes on, you'll start to see more research coming out of this center. The other thing I'd like to point out, or the other team, is the Quantum Solutions Lab. And so this is a collection of experts in the area of quantum computing, machine learning, and even high performance computing. And they're there to work with our customers, right? Their goal is to sit down with our customers, understand what it is that what their use cases are and what their pain points or problems are, and then work together to find a solution for them, be it classical or quantum. And we think this is very important because we want to look at problems holistically, right? We all know that quantum computers are still kind of in their infancy. And so while we look to find meaningful applications and quantum solutions, it's very important that we compare that to and also build out some of the best classical solutions that we have for our customers. It's okay. Let's go back to Amazon Braket here. As I mentioned, it's a fully managed service, and it makes it really easy for scientists and engineers who are familiar with quantum computing to go ahead and design, test, and run some of their algorithms. But it's also a very good platform for those who are just generally interested in quantum computing and want to learn more about it, right? As I mentioned, we design, test, and run. And so we provide these managed environments like Jupyter notebooks or managed Braket notebooks, and they come pre-installed with certain algorithms, examples, as well as the Braket SDK and other tools. And you can, once you design your or have an algorithm you'd like to play with or an application, then you can go ahead and test them on our high performance circuit simulators if you'd like, before running them on secure and on-demand quantum hardware. Okay, so with that, let's jump into the Amazon Braket architecture itself. So what I'll do is represent the AWS cloud by this white box here. And so within AWS, as I mentioned, Amazon Braket is one of the many services that we have. I'll go ahead and represent it by this orange block. Now our users can interact with this service in a number of ways. Some of them are managed notebooks. You can access it through your local IDE. And then we also provide an Amazon Braket management console, and we'll cover these in a hands-on demo. We provide our customers with access to two types of simulators, circuit simulators. The SV1 simulator, which is rated for about 34 qubits. And we also have a TN1 simulator that works well for or up to about 50 qubits. Now, in addition to these simulators in the cloud, we provide you with access to a number of QPUs. You see here, we provide access to the Braket device and also the IonQ device. And what's important for today is the D-Wave devices. And you see that we provide access to two of their devices, both the 2000Q system, as well as the Advantage system. Now, again, Braket is just one of many services. And so we've integrated Braket with a number of them. For example, we have something known as S3, which is our object storage. And when you run or submit tasks within Amazon Braket, the results of those calculations are sent to your Amazon S3 bucket. And we'll cover this in the demonstration here in a little bit. Another service I'd like to point out is Identity and Access Management, or IAM. And what this service does, it allows you to securely manage the access to your AWS services. You can create users, groups, and roles and attach permissions to them to determine how it is that your users access this service or use Braket. A good example of this is at times when people are starting to get used to quantum computing or up and running with our service, they'll choose to block access to the QPUs and have their users start to get familiar with the service and its capabilities using the simulators alone. And after that, then removing those restrictions and systematically providing their users with additional access to the service. A few other services I'd like to point out here. Amazon CloudWatch for monitoring. What this does is it collects raw data and processes it into readable near real-time metrics. And so you can view historical data up to about 15 months with CloudWatch, and it comes with its own console. And what this does is it allows you to get a better perspective on how it is that Amazon Braket is performing. Another one of interest to many of our customers is Amazon Event Bridge. What it does is it monitors the status and changes events in Amazon Braket tasks. And what this can do is it can trigger automatic actions. And then finally, security is number one for us at AWS. And so we have the key management service. And what this does is it allows you to easily create and manage cryptographic keys that help you to control access to a wide range of AWS services and applications. All right, so how does Amazon Braket work? Well, I'd like to first introduce the idea of quantum tasks and shots. And so a task or a quantum task in Braket is the atomic request to a device. And so for example, for a gate-based device, this would include the quantum circuit, including measurement instructions and other metadata, and the number of shots. And we'll get into what that is in just a minute. For annealing devices, this includes the problem definition, other optional parameters, and again, the number of shots. So what is a shot? Well, a shot is a single circuit execution and measurement. And so again, for a gate-based device, you may send a task to Amazon Braket, which contains the quantum circuit, and then the number of shots, so the number of times you'll execute that circuit on your QPU. And for D-Wave devices, for every task, we support up to 10,000 shots per task. Well, how is it that we charge you for this service? Well, Amazon Braket is like all of our other services, a pay as you use, or you only pay for what you use, right? You get your resources on demand, upfront, without any commitment. And so we charge our customers on a per task and per shot basis. And so here on the table on the left, I list the QPUs that are available to you, the 2000 Cube, Advantage, IonQ, and Rigetti Aspen 9. And you can see that for every task that you submit to a QPU, you're charged 30 cents. And then the per shot price changes depending on which QPU you use. So let me give you a quick example here. Let's consider a situation where we are using the D-Wave Advantage device, and I send it one task with 10,000 shots. And so here it would be 30 cents for the task plus 10,000 times the per shot price for a total of $2.20. Okay, so when you send a task to Amazon Braket, what is the flow here? Right? How is it that your task proceeds and everything is processed? Well, first, what a user will do is they'll go ahead and define an annealing problem or a circuit, for example. And then they'll choose a device using the Amazon resource name or ARN. And I'll show you how this works in the demonstration in just a little bit. From there, they'll submit a task, and that'll go to Amazon Braket. And your task will be queued until the device becomes available. Then once it's available, that will be processed. Amazon Braket will return the results to your S3 bucket. And again, in the hands-on demonstration, I'll show you how that works. And then the SDK pulls the results and loads them into the notebook as well. So that's just a brief introduction into AWS, the quantum computing effort, and Amazon Braket and how it works. If you'd like to learn more, I'd like to encourage you to go to the Amazon Braket webpage, and you can click on the Getting Started link. And what that will do is it will redirect you to the Amazon Braket documentation, or a page with a link to the documentation. Right? You can go ahead and look at the developer's guide. There you can learn about Amazon Braket terms and concepts, more about the devices that we support, pricing. There are some getting started examples. Also covers how to run hybrid algorithms. You also see here on this page, you have access to the API reference and the Braket Python SDK. So I encourage you to take a look at those. Another thing I'd like to point out before moving on to the hands-on demonstration is that we have the Amazon Braket Ocean plugin. So this is Git repo, and you can see, you can take a look at this open source library that provides you with a framework that allows you to interact with the Ocean tools on top of Amazon Braket. And then finally, we have an Amazon Braket example repo. And so what this does is it provides you with a number of notebooks to show you how to get up and running with Amazon Braket, again, with some hybrid algorithms, some quantum annealing examples, and so forth. And you'll also see that these examples are pre-installed on the Amazon Braket notebook instances, and I'll show you that in the demonstration. Okay, and so with that, let's go ahead and move over to the demo. We've gone ahead and pre-recorded it. I actually recorded it last night. And so let me go ahead and stop my screen share right now, and then go ahead and pull it up. Give me a quick second here. All right. All right, let's get started. To begin with, let's go here to the top right and click on Sign into the console. What I'll do is enter my account alias, so Ty AWS Quantum, my username, Braket user1, and my password. Let's sign in. Here's the AWS Management Console, and you can see at the bottom is a list of all of our services. But today we're interested in Amazon Braket. So let's go to the top here and search for Amazon Braket. Under Services, we can click on Braket, which brings us to the Braket Management Console. And you can see that it defaults to the Devices tab. You can see here that we have access to 7 devices, 5 QPUs, and 2 managed simulators. Let's go ahead and click on the Advantage system. If you click on one of the devices, you're provided with additional information about this device. And there's a few things I'd like to point out. First is that each one of our devices lists its availability. Second is that they each have a device ARN, and this will become important later. Over here to the right, you see our cost. There's a per task cost as well as a per shot cost. Please note that the cost per task is consistent throughout all QPUs, but the price per shot changes depending on which QPU you select. And finally here you'll see that we're in the region US West 2. So the D-Wave Advantage system is available in the US West 2 region. Just to remind you of what a region is, let me go up here to this tab and show you a map of the AWS global infrastructure. What you see here are blue dots, which represent regions. Amazon Braket is available in 3 regions. The first, Northern California, or US West 1. The second, Oregon, or US West 2. And the third, Northern Virginia, or US East 1. So let's go ahead and go back to the tab with our Braket Management Console. And if I go to the top right here, I can check my region, and you'll see we're in US East 1. Okay, let's go back to devices. If I scroll down and now click on the SV1 simulator, you'll see again the device availability, the device ARN, but now we see that the SV1 simulator is available in 3 regions rather than 1. And finally, we see that the managed simulators are charged per minute. Okay, let's go to task now. You see that I currently have no tasks in this region. Just to remind you again, we're in US East 1. What we'll do now is go to a notebook, start up a new notebook instance, and submit a task to a QPU. And then we'll come back here and check on our task. Let's move over here to notebooks. You can create a new notebook instance by going to the top right here and clicking on Create Notebook Instance. We can name this instance, and let's call this one New Instance. We can also select the instance type. You see that we have a variety of instances available to us. But because this is a demo, we'll just stick with the MLT3 medium. All right, let's scroll down a little bit here to permissions and encryption. Now, if this is the first time and you're enabling Braket, you'll see the option to create a new role. However, I've already enabled Braket on my account, so let's go ahead and use an existing role. And just to remind you, IAM is a service that helps you securely control access to your AWS resources. Okay, let's go ahead and create a new notebook instance. And you see this notebook instance is pending. Now this may take a few minutes. So what I've done is I've already created a notebook instance, Amazon Braket user, and you'll see that it's in service. So let's go ahead and access this. Every new instance has a pre-installed folder here, Braket examples. Let's go ahead and click on it. And you see we have these subfolders with various topics, and let's go into the quantum annealing folder. And you'll see here we have a number of example notebooks. And so I encourage you, if you're interested, to go ahead and take a look at these when you have the time. Let's go back. All right, let's go ahead and start a new notebook. And we'll start our hands-on session. Okay. So what I hope to accomplish here is to show you how to get a little bit of information about the devices that you'll be using here in the notebook. And then we'll go ahead and solve a simple example of the minimum vertex cover problem. So let's get started. I'll import a few things first. So from Braket.aws, let's go ahead and import AWS device. Also go ahead and Braket.ocean plugin. Import Braket D-Wave sampler. And we'll use this for a minimum vertex cover problem. We'll also go ahead and import matplotlib. Go ahead and import network X. And D-Wave underscore network X. And finally, D-Wave composite. All right. Now to help us here, I have a few helper functions. And to save you from having to watch me type these out, let me go ahead and just copy and paste them into these cells. First is get colors. The second, get graph. And the third, get colored graph. All right. Okay. So now let's first set our instance, our device. We'll use AWS device. And we'll have to provide it with the device ARN. So if you remember, we can go here, this tab on the left, where we have our Braket management console. Click on devices. Click on D-Wave Advantage System. And then down here, we have the device ARN. We'll go back to our notebook. Go ahead and put that there. Okay, now that we've set our device, let's get some information about the device. For example, device name. Or we could get the number of qubits. How about the number of couplers? And finally, let's see if we can get the number of shots per task that we're able to specify. You see, earlier I mentioned that you can get up to 10,000 shots per task with the D-Wave devices. All right, well, let's move on now and set up our S3 bucket. If you remember, Amazon Braket puts the results of your calculations into an S3 bucket. And so we need to go ahead and provide that information here. I've already set up a bucket. So let me set it here. Say my bucket, Amazon dash Braket dash users. I just want to point out here that, oh, let me see, I have an error. Users. That if you're using the standard Amazon Braket full access policy, that all of your S3 buckets will need to start with the prefix Amazon-Braket. Let's go ahead and specify a folder within our bucket here. We'll call it simulation output. Then we'll tie it all together in S3 info. Okay. Next, let's go ahead and set our graph. So today what we'll be using is a graph with 6 vertices and 5 edges. Let's say n equals 6. And we set our graph equal to an x our graph. And then finally, let's go ahead and call one of our helper functions on our graph. All right, here we go. So if you remember, the minimum vertex cover problem says that we'll have a unidirectional graph. And again, here it has a vertex set V with 6 vertices and an edge set E. And in this case, we have 5 edges. And we define a vertex cover as a subset of these vertices such that the edge of such that each edge in the graph is incident to at least one of the vertices in the subset. And if we minimize that, here you can see that the solution should be the vertex in the middle. Well, let's go ahead and solve this, but first we'll have to set up our sampler. Let's say sampler is equal to bracket D-Wave sampler. We'll provide it with our S3 info, as well as the ARN. Now I know we have the ARN above, but just to remind you, let's go back to the Braket management console. And if we were to click on devices, then the D-Wave Advantage system, again, we would find the device ARN down here. Let's go ahead and paste that. Enter. And then use embedding composite. Sampler. All right. Now let's go ahead and get our result. T and X, minimum vertex cover. And what we'll do is provide the graph and the embedded sampler. Okay, and when I hit enter here, what this will do is it will submit a task to D-Wave. D-Wave device. Let's go ahead and go back to the Braket management console. And I'll remind you that the Advantage system is available in the US West 2 region. Right now, we are in the US East 1 region. Let's go ahead and look at our Task tab. And if you recall, earlier we had no task here, and even though we've submitted a task to the D-Wave Advantage system, we don't see a task here. And that's because the task will show up in the region where the device is. So in order to see the task that we've just submitted, let's go ahead and change our region from US East 1 to US West 2. And here you'll see our task, and it's completed. Let's go ahead and click on it. Provides us a little bit of information. You see we have a quantum task ARN. Again, the status is completed. And we have the device ARN, which says that we submitted it to the Advantage system. The task had 1,000 shots. And here's a link to our S3 bucket where our results are stored. If we click on that, you see we are in Amazon S3, the Amazon Braket users bucket, simulation output. And the results here are stored in a JSON file. At the same time, the SDK will pull the results. So we'll be able to access that here as well. Let me go ahead. If you recall, we expected that the result, or the minimum vertex cover, would have the vertex in the center here. Let's go ahead and return that result and plot it. So and we use our helper function. Give it graph. Well, then, oops. And here you go. You see we return the appropriate result. Center vertex. We can also print out result. Okay. So now before wrapping up, I'd like to point out one other thing. Let's go ahead and go back to the tab where we have our AWS management console. And I'll type in Amazon Braket. There we go. Get back to the Braket management console. Again, we're here in Northern California. So let's go back to where we started our notebook instance in US East 1. Click on Notebooks here. And you'll see that the instance that we started earlier, Amazon-Braket new instance, is now in service. Now you're charged whenever your instances are in service. And so when you are done working, we strongly recommend that you go ahead and stop these instances. Let me go ahead and stop both of these now that we're done with our demonstration. And with that, that completes our demonstration. So thank you very much for your time.
Thanks, Dylan. A few comments. I know we had some issues with the clarity of the demo, so we'll see how the recording turns out. And if the recording of the demo is good, then you can see the webinar and the demo portion on the D-Wave YouTube channel in a day or so. If it turns out the demo is not very clear, the resolution is not very good, we'll work with Amazon to make sure that we have one. And again, we'll also post it on YouTube. So sorry for any inconvenience there. We did get a lot of questions during the talk, and we have a number we're going to ask live now. If you have any questions about what Tyler has gone through or about D-Wave technology, please put it in the Q&A box. We have panelists who can answer, but I will now ask Tyler some of the questions we decided to reserve for out loud. Tyler, in the case of D-Wave, how is a shot defined? Does the annealing time affect the price? And you're on mute, I think.
My apologies. Yes, so for example, if you want to get a distribution of samples from the D-Wave device, each one of those samples would be a shot. And no, the annealing time does not affect the price. So the pricing it's very standardized. It's 30 cents per task, and then the per shot price depending on which QPU you use.
Okay, thank you. A question about hybrid solutions. What could be your suggestion to implement hybrid solutions in AWS? Do I have to implement my own algorithm to handle?
Right. So at the moment, you're provided access to the D-Wave devices, and you would have to go ahead and implement your own hybrid device, hybrid algorithm. Um,
Okay. Is it possible for me to use Penny Lane with D-Wave in AWS?
that's a good question. There aren't any D-Wave specific features on Penny Lane that I'm aware of, but there are some icing model representations, I believe, that may be applicable there, but I'd have to check.
Okay. Would I need a specific token for every different provider, or is that managed by Amazon Braket?
So Amazon Braket is a fully managed service that manages your access to the QPUs in the backend. And so once you log into your AWS device and you set the appropriate permissions for yourself or any of your users, then your AWS credentials are what are necessary to access the QPUs.
Okay. Is an ARN unique? For example, if one logs in on a different day, will that be different? So should not be hard coded?
Okay, yeah. So the ARNs are unique. They're fixed, and so when you go into your Amazon Braket Management Console, as I showed you in the demonstration, and you can go ahead and copy that. But there is also a way to get the ARNs, I think, through the SDK as well.
Okay. How is quantum loss addressed?
That's a good question. And to be honest, I'm not sure how it. I'm not entirely sure what the question is here. Guess maybe please feel free to reach out to us after, maybe put it into a little bit more context there, and then we'll be able to understand what it is that you're getting at here.
Okay. Is there any path in AWS where we can use QML? I mean,
Yes.
bracket and QML.
So Braket does support Penny Lane, and so that provides you with a range of tools and functionalities for QML.
Okay. Is it possible to port the algorithm implemented based on D-Wave to other QPUs? Any major changes to be considered?
Right. So we provide access to 3 QPUs, and 2 of them are gate-based devices, and the D-Wave devices are annealing devices. And so there would be changes there. Going between the 2 gate-based devices, depending on which gates you're using, you may not have to make many changes to your algorithm.
Okay. Can I assume a task is equivalent to the submission of algorithm to the QPU?
I think it depends on your algorithm. For example, if you were to perform a hybrid algorithm, that would require the submission of many tasks.
All right. Well, I think that is the last of our questions here. Well, let's see. Just one more came in. Let's see. On Leap platform, you could send problems to the machine only as BQM. One way of doing this was with Python dictionaries. Can we do the same here?
I believe so, right? So we provide an Amazon Braket plugin that lets you interact with Ocean and use those tools. And so I believe you are able to submit it with a dictionary through Python as well. But
Okay.
I'll have to check. Please feel free to reach out to us if you're not getting a satisfactory answer here. We'd really like to understand how it is that you'd like to use this service, and would be very willing to and excited to work with you to get you up and running.
And what is the best way for someone to reach out with follow-up questions, Tyler?
Oh, yes. So you can go ahead and reach me or anybody else here, either through your AWS account team, if you do have one. If not, you can find me through my email address here. Susan, where should I provide that?
You want to put it in the chat for everybody?
Sure.
Okay, so while he's doing that, again, we thank you for coming. Again, we'll make sure that we have a good recording of the demo, and we'll be sending you out an email by the end of the week with links to the recording of this webinar. And again, if the demo does not come through clearly, we'll send you a link to a demo recording as well. So thank you all for attending. Keep watching for our emails for our future monthly webinars. And again, thanks very much to the AWS team and the Braket team for joining us today and doing this webinar. Thanks, everyone. Hope you have a great day.